Problem 19. A square with side length x is inscribed within a right triangle of side lengths 3, 4, 5. So we have this right triangle right here with side length of x, such that one vertex of the square coincides with the right angle of this triangle. A square with side length y is inscribed in another right triangle as seen right here, and we know that the triangle is also the same right triangle in terms of having 3, 4, 5 sides. What is x over y? So basically, we're trying to find x over y, so let's first finish drawing out our shape. Write each length in terms of what they actually are. So we know, for example, that this side is 3. If that's 3, then that means this is 3 minus x. And likewise, this is 4 minus x. This is, and this entire length is going to be 5. So I'm going to say that is just 5. Now, the right triangle right here is much easier to solve for, so let's first solve for that. We always want to relate it with sides that are given, and we know that this creates a bunch of similar right triangles because we know this is right angle, this is right angle, this is right angle, and this is right angle. This is important because we also know this is a right angle. If that's a right angle, let's suppose this is angle A, this is angle B. We know that A plus B is equal to 90 degrees because we know that they must form a straight edge. If that's a straight edge, that means this must be A because this is already 90 degrees, and this must be B. Therefore, from angle, we have angle similarity. This right triangle is similar to this right triangle, similar to this larger right triangle, because they all share the same angles. Now let's consider how to solve this question. We know that EF, right, over CE, EF over CE is equal to FD, right, over AD. Right, it's the base height and base height similar. So the symmetry. So EF is 4 minus x, CE is x, and we know that FD is 4, and we know that AD is 3. So therefore we can solve for x. And I chose these specific side lengths because I know what they are. 4 minus x, 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 3 minus x. So always related to given sides that you already know. In this case, 4x is equal to 12 minus 3x, therefore x is equal to 12 over 7. If x is 12 over 7, we are halfway done because now we need to solve for y. How do we solve for y? Well, to solve for y, we have to employ a little bit of a unique tactic, which is this is right angle, that's y. Now, let's suppose this is angle A, that means this is B, that is angle A, the right angle, that's going to be angle B, that's going to be angle A, and that's going to be angle B. Now, this is a 3, 4, 5 right triangle, right? So what can we say here? Well, we're going to have to employ a bunch of symmetry here, which is that we want to relate it with given sides, but we don't know what these sides should be. So we know that, first of all, we know that this is 3, and this is 4. In this scenario, and we know that this is 5, right? We have to create a bunch of right triangles again, and we must use them to our advantage. So let's say this. Let's say that, for instance, this, I'll call this what? I'll call this x. So this is 4 minus x. And let's call this side length c, so this will be 3 minus c. So we know that 3 minus c over x is the same thing as what? 3 minus c over x, so 3 minus c over x is the same thing as AD, right, over DG, which is the larger right triangle, which is equal to 3 over 4. And now let's use another right triangle. Let's use this right triangle, right? Actually, we shouldn't be using 3 minus c, because we always want to relate it to given information. We want to relate it to y, because we're trying to solve for y. So instead of doing that, let's do CD, right, over CE, right? CD over CE is AD over AG. Now, what is CD? CD is 3 minus c. And I don't like 3 minus c. Let's not use c. Let's just keep it simple. Let's keep it as DE. Right? So it's constantly changing. Just keep thinking through it. So DE over CE is the same thing as DG. So this would be a G. GD over AG. So that means DE in this case is x, and we know that CE is equal to y, which is equal to GD. Well, GD is 4 and AG is 5. That's the first equation. Now let's consider the second equation. We can use this right triangle right here. We know that 4 minus x over y is the same thing as the hypotenuse 5 over the over y, so that must be the base. The base is angle A with the right angle, so this has to be 3. So now we have two variables, and we can solve for each variable. Note that this x is not the same as the x we solved previously. So that means what? We know that 5y is equal to 12 minus 3x, and we know that 4x is equal, or 4y rather, 4y is equal to 5x. So we know y, for example, is 5 over 4x, so we substitute it. So that means it's 25 over 4x plus 3x is equal to 12. Therefore, 412, so 1237x is equal to 12. And therefore, x is equal to 12 times 4 over 37. But that's actually a very bad substitution because we're trying to solve for y. Sorry about this. So that means x is equal to actually 4 over 5y. If x is 4 over 5y, 5y is equal to 12 minus 12 over 5y. Right? Because we simply substituted x is 4 over 5y into this formula right here. So after we do this, we know that 5y plus 12 over 5y is equal to 12. So y must be equal to 12 times 5, right? 25 plus that is 37. So that must be equal to 60 over 37. And 60 over 37 is y, and x is equal to 12 over 7, so that means x over y is the same thing as 12 over 7 times 37 over 60. So this gets canceled into 5, and we get 37 over 35. So your final answer will be answer choice D.